Good evening, everyone. This is Prashun sir, and I am here to inform about the topic called allotropy and allotropes. This is a very important topic in the chapter carbon and its compounds, and it becomes very important also to explain. Now, coming to the topic, allotropy or allotropy and allotropes. The phenomenon by the virtue of which any element exists in more than one physical form is known as allotropy, while the various physical forms in which the element exists is called allotropes or allotropic modification. So if we take carbon as an example, now carbon exists in various forms. Let's consider the pure forms, that is diamond, graphite and Buckminster fullerene. So these are the different physical forms in which carbon is observed to be existing, and hence we can say that carbon have allotropes or allotropic modifications as graphite, diamond, Buckminster fullerene, and the whole nature in which carbon is available in various forms may be expressed as the allotropic modification of carbon. So a question may come, are there any elements which exist in allotropy? Answer is yes. If you take the example of sulfur exists as allotrope. We know that rhombic sulfur, monoclinic sulfur and plastic sulfur are also allotropes of sulfur. In case of phosphorus, we have red phosphorus, black phosphorus and white phosphorus as the allotropes of phosphorus. Now coming to the allotropy of carbon. If you come to allotropes of carbon, they exist in two forms. First is the pure form, other is the impure form. In pure form you get diamond, you get graphite and you get Buckminster fullerene, and here you get, first is coke, then comes coal, then comes lamp black, this comes as gas carbon, the fifth one is charcoal. Charcoal are of three types. First is called wood charcoal, then comes sugar charcoal, the third one is called animal or bone charcoal. So these are the various Allotropic modifications of carbon. Now a question may come, why we are so interested to study about carbon as a whole. It comes under the general introduction of the chapter, but still I mention, now carbon is actually a versatile element, and the uniqueness or versatility of carbon leads to its studies because carbon forms a very class of compounds called the organic compounds. So now what are these unique characters? The first of them is called catenation. The second unique character is the nature of carbon to stay electrically neutral. Carbon never prefers to be electrically positive or electrically negative. It goes for sharing of electrons. The third point, which is very important in this case, is electronegativity. And the fourth point that is also very important is actually called the tetravalence of carbon. That means carbon is having 4 electrons in its outermost shell, by which it goes for sharing. And what are the outcomes of these? You get various types of compounds of various structures like chain structure, ring structure, then cage compounds, various types of compounds you get. First is this. Second, if you see carbon, you get allotropy, where all these characters you can see. And the other thing that we get is various types of mixed compounds. So in this video, I'm just ending up here because the chapter is very big. So allotropy, I hope the things are very much clear. So this is actually the class of the various allotropic modifications of carbon. This is the pure ones, these are the impure ones. So this is in the topic I meant to say. So I hope everybody understood it. So good night.